Hello and welcome. This is Padmaraj, Assistant Professor, Department of Mechanical Engineering, SDM Institute of Technology, Ujjain. So, in this session, we will discuss on the topic Bevel gears, which is Module 3, in the subject Design of Machine Elements 2. So, what are bevel gears? First question comes to you. Bevel gears, as you can see, we can connect the two shafts which are at right angles to each other, which I have shown here, and also we can connect the two shafts which are less than 90 degree, which can connect more than 90 degree. That's why it has range of applications. We can employ it in automobiles, to small scale industries we can apply. So applications are plenty in automobiles. So coming to the design parameters which are there for bevel gears, based on different types we will be designing the bevel gears. Here in this case we have two types of bevel gears. One is based on the shape of the tooth and one is based on angles at which shafts are connected by using bevel gears. As you can see in the two images which are animated images I have shown here, one is a straight teeth is connected by the input pinion and the driven gear, and one more teeth where the shape of the tooth is inclined. So as in case of helical gear we have discussed, same thing goes here. Based on shape of the tooth we can have two types of bevel gears. One is the straight or parallel teeth bevel gears, and one more type is helical tooth, or we call it as a spiral bevel gears. Both provide a different advantages and disadvantages. As you can see in case of straight bevel gears, so engagement and disengagement of teeth are very rapid and it will create a noise. There is no continuous contact between the pinion and gear in case of straight tooth bevel gears. While in case of spiral bevel gears there is a continuous contact because teeth are inclined, and the smooth engagement and disengagement will be there in case of spiral bevel gear, where we can have less noise compared to straight tooth bevel gears. That's why we will use based on wear conditions. If I see, so straight tooth bevel gears have more wear compared to spiral bevel gear. That's why straight tooth bevel gears are restricted for limited power applications, as spiral bevel gears, since it has less noise, less wear rate, it can be employed in high power transmission. So that is based on shape of the tooth we can have these two types of bevel gears. When you come across next type, that is based on angles, we have different types. Basically acute angle, obtuse angle and right angles. Where you can see acute angle is nothing but where shaft angle, which is represented by theta, which is less than 90 degree. So if the shaft angles are less than 90 degree, then if I connect the bevel gear by using the bevel gears, we can call that type of bevel gears as acute angle bevel gears. Here, as you can see, here this figure shows where theta is the angle where it is less than 90 degree, it has been connected, and delta 1 and delta 2 are the pitch angles that will be discussed in the later session. And similarly, obtuse angle bevel gears are the angles where you can have theta which is greater than 90 degree, where the shaft angle in which bevel gear is connected. So that type of gears we call it as obtuse angle bevel gears, where in this case theta is greater than 90 degree. And more importantly, we have in this case we have different three varieties of bevel gears, where you can see one is special where it is greater than 90 degree and theta will be equal to delta 1 plus delta 2, where delta 1 represents the pitch angle of pinion and delta 2 represents pitch angle of the gear. Similarly, as you can see in the second case of obtuse angle bevel gear, where theta is greater than 90 degree and you can have delta 2 which is greater than 90 degree, this figure, where you can see here when compared to this obtuse angle bevel gear, this angle where delta 2 is greater than 90 degree, you can observe in this case where delta 2 will be greater than 90 degree. So thereby this is, we call it as an internal gear, where the pinion will be connected internally to the gear. So in this case it is externally connected, in this case it is internally connected. So in this case, as you can see, in delta 2 is 90 degree, that means delta 2 is equal to 90 degree, and delta 1 is theta minus 90 degree, the remaining angle. So this type of gear we call it as a crown gear. So we have three varieties in case of obtuse angle bevel gear, and last based on angle is right angle bevel gears. So right angle bevel gears are the gears where the shaft angle will be at 90 degree to each other, where you can see theta will be delta 1 plus delta 2. It's a typical or classic right angle bevel gear. And next type in the same right angle bevel gear is meter gears. So in this case, meter gears, where you can see pitch angles of both the pinion and gears are equal, that is 45 degree. So you can see here delta 1 and delta 2 are equal to 45 degree. So this is about the types of bevel gears. So now we move on to terminologies. What are the terms involved in designing the bevel gears? As you can see, we have the different terms which are basically employed in designing of gears. One by one we will discuss. In this case, first one is the pitch cone. So pitch cone, as you can see, pitch cone is nothing but where it is the imaginary surface which is drawn on the teeth surface, or we can call on the surface of the teeth we can draw one line, and similarly at the other end of the teeth we can draw one more line. So where two lines are intersect each other, so if I connect all the tooths with respect to the axis, you can see that imaginary surface. That imaginary surface we call it as a pitch cone. And similarly, cone center. So cone center is nothing but where it is the point where the pitch cone will be coincided, or the pitch lines will be coincided. As you can see in this case, the axis of each teeth will be coinciding with this one single point. That point we call it as cone center. And third term is pitch angle. So pitch angle, as I have represented here, delta 1 and delta 2, which is nothing but angle made by the axis of the gear to the pitch line of the gear, we call it as pitch angle, and it is represented by delta. So angle made by the gear axis and the teeth axis or the pitch line, we call it as pitch angle. Similarly, we have addendum angle. So addendum angle is nothing but where from the apex point to the surface, where the theta A, you can see that it is the projection which is made from the axis of the tooth to the upper surface, to the addendum. We call that as addendum angle. That means it is made through the pitch line to the top surface of the teeth. This angle we call it as addendum angle. Similarly, dedendum angle is nothing but it is the angle made by the tooth, root of the tooth to the pitch line. We call that as the dedendum angle. So similarly, we have face angle. So face angle is nothing but from the surface of the tooth, outer surface of the tooth to the axis of the gear, we call it as face angle. Similarly, root angle. So root angle is nothing but it is the angle made by the tooth bottom surface. You can see this is the bottom surface of the tooth and the axis of the gear. We call that as root angle. Root angle. And similarly, back cone. So back cone, as you can see, it is a line or it is the cone which is constructed perpendicular to the pitch cone or pitch line, we can say. As you can see in this case, it is the perpendicular line which is drawn to the pitch line or the surface of the teeth. We call that as a back cone. And back cone distance, last one. Back cone distance is nothing but it is the distance of the back cone which is made from the axis to the tooth surface. That distance of the back cone, we call it as back cone distance. So these are the different terms of the bevel gear, and in this session we have discussed the terms and also types of bevel gears. So thank you for watching.